Welcome back to the Data and AI Specialist track at PyCon AU 2025. And there are so many faces here. How exciting. Now, I'm very excited to introduce our next speaker, Boaz, and I can't wait for your talk. So please, big round of applause for Boaz.
Good morning, everyone. Hi, I'm Boaz. It's great to see you all here. I'm going to tell you a bit about a Django application that I've been working on that's used for the assessment of power infrastructure, specifically transmission lines. And my goal for this talk is to tell you all a bit of a story. It's a Django in the wild situation. So I want to tell you about the architecture, the implementation, some of the things that we find really useful. I hope you guys find something useful out of this talk. Before I go into it, I'm curious, how many people here use Django? Can I get a show of hands? Okay, that's a decent amount. Just so I know how much detail to give. So first I should introduce myself. I'm Boaz. I studied mechatronics engineering here in Melbourne. Then I worked in control systems for a while. Here's a self-driving bicycle that I built. That was actually done with Python. That's a talk for another time. But that was test equipment for autonomous vehicles, which I also spent some time building. Here's one of them. Now I do full stack software engineering, specifically Django, and I do it at Radine Systems. I'd like to say thank you to Radine Systems for letting me present this content. It's pretty special to put the guts of an application on display. There's a lot of intellectual property considerations. I'm going to swim between the flags here, but I think I've got plenty of stuff to tell you about. But yeah, quite generous of them. And so Radine Systems started in 2018. They built this camera system that tracks conductors. It gets helicopter mounted, flies along the lines, captures lots of photos. Before I go in a bit further, I just wanted to say, speaking of guts on display, I think that's the best thing about the software engineering industry is that we can share our stories, and I love this community, and this is sort of me wanting to give back. So here's the system mounted in the helicopter flying along the lines. Each camera is capturing 5 frames a second of very zoomed in imagery of the conductors, and we're looking for things like this: broken strands, damaged hardware, stuff that can take down the line, cause disruption, or even worse, cause bushfires. It's very expensive to repair these things. It's very expensive to maintain them. So the goal of this application is to find the needle in the haystack, the tiny break, because it's not all broken, and increase the service life of these assets. The thing is, it's huge scale. We often talk about scale in tech, requests per second, but in the energy industry, scale's also critical. It's just measured in kilowatts and kilometers. So that's why we use a helicopter, because it takes 3 minutes to cover this distance. And when you think about the transmission network of Australia, there's 58,000 odd kilometers of line. But that's span to span. Actual conductor distance could be 8 times higher. Like you see on this tower, there's 3 phases on each side, plus the 2 earth wires. So if you want to check those, the problem just became 8 times bigger. So we have this mental model of how we break down the problem. It's like the data funnel, I suppose. You have your images that you capture, and then you use machine learning to do some of the heavy lifting and to detect anomalies. And then we have a human in the loop to go and verify them. And because we want to oversample, missing anomalies is really bad. So we oversample, use a human in the loop to correct that. And so this is that workload reduction. And then you can pass that on to your customer, and they can do something about it. So just a little bit about the storage of this, or the data that we're holding. We probably have about 400 terabytes at the moment. That's not all images, because we capture a lot as we're flying, but then we also capture video. We have to keep backups. We compress the images down to thumbnails. And and we self-host all of this. The application started in 2018. Cloud wasn't as big back then, and we did some research into moving all of this into the cloud. It didn't work out last time we looked at it. If there are any cloud providers here, I'd be happy to speak to you later. But we also used to do our training and inference locally. We had GPUs in the data center. They got obsolete very quickly. And they also charge you for electricity consumption. So we do use cloud for that. That's all I want to say about storage. I think it's time to talk a bit about the application. So yeah, I want to tell you about how we do our inferencing, how we then filter all of these images, how we present the data to customers, and some useful Python stuff or Django stuff that we have for the geographic queries. So inferencing, if I had to summarize this section, the answer is rate limiting. We have these two models, a processing batch and a processing batch image. So when you want to run your model on some images, we create a batch that creates all of these associated images that we specify that we want to run through the model, and they go through this locked and done flagging system. So let's say one of our models detects all of the hardware, another one then goes and classifies it further. So we create the batch, then the VM asks for the images in that batch. It dribbles out 50 images, or what I've picked a magic number, and they're all locked at this point. Then we get the features for each image. We get the features that we want to classify. They go into the VM, and then the classified features come out. The images are unlocked and marked done. And so often, like corrupt images, for example, will remain locked and not done. It's a pretty good system for us to manage that. And the result is you get these features. You know which model they came from, and it's just a very simple bounding box, and it's linked to an image. And so this is a table with millions of rows. And it's so powerful because we can filter. Show me all of the images with broken strands. Done. Show me all of the dampers. Done. We can put it on a map. We can do a lot of useful things out of the box with the Django ORM for this. It needs a bit of optimization at that scale, but out of the box straight away. And because there's some Django people here, I want to tell you about the MPTT hierarchical model. So that's how we classify our feature types. It's amazing for hierarchical data. So this example is a genre of, I don't know what the genre of, but it has you create a genre and you can have a parent, and so that's how you get that tree. And you can very quickly get all of the descendants of a node or the ancestors. So that's used a lot when we do our classifying. Like if you have an insulator, you want to say which type it is, it grabs all the types and it chooses the one it wants. So at this point, we now have all of these defects that we want to, or anomalies that we want to assess. And so we do that using reviews. So you filter down on the images that contain a feature, and then you add a review. That anomaly type ID is another MPTT model because it's a bit of a tree structure. And you can filter on reviews as well. So we really rely on the ORM here. It's amazing. A really cool package that we use on this one too is called Django Simple History. So if a user goes and edits their review, we can keep track of that. It's internal auditing. But that's probably still too slow for the scale that we're working at. So we built this internal tool called the image grid, which lets you view all of the detected features in like this big scrolling page. And you can very quickly verify the actual true positives that were detected. So because we oversample, there are some false positives, we need to filter them out. So we do that with reviews. And the output is an image report or a map-based report, but this is our image report. And it's really useful because you have a shareable link. Customers always want PDFs. So when you have a report with a few hundred images, rendering that into a PDF in the browser doesn't work so well. So we do that on the server side. I want to show you how we do that. So it's the important thing here is that HTML argument. It's a string containing HTML that's rendered from Django templates. We use this library called XHTML to PDF. It has a method called a function called pisa, and that just takes the HTML string and creates a PDF. There's a bit of nuance to it because they have a very restricted subset of CSS you can use when you generate your PDF. And another bit of magic to get this working for us was that link callback part. PISA requires the actual image, not a link to the image, so we had to get a way to sort of grab that out of the request. I can talk to anyone about that later if they're interested. But I just want to show you how we actually do it. So there's a few templates that are used. There's a title page template, image report, title page.html. It's a standard Django template. It takes those context arguments in the dictionary and just renders them for the PDF. There's some formatting that needs to be done. That's the title page. Then the cards get their own template, image report card print. That's a great name. What's cool about this one is you add a PDF next page for between every page. It's that easy. And then finally, they get combined into the image report PDF template. That sort of handles the layout of the content on the page. You have your title, you have your cards, but you want to have a watermark, you want to have the logo in the top. So that's how we do it. The next thing I want to talk to you about is GeoDjango, how we do our geographic queries, because at the end of the day, if you have the photos, it's not very useful if you don't know where they're taken. So we have an interactive front end that shows the electricity network. Users can click on the map, see the images close to where they clicked, see the hardware. So that's what we do. GeoDjango has a few primitives. It has a line string field, a point field, and a polygon field, and then it also has their multiples, like a multi-line string, multi-point, multi-polygon. So you can define that in your model, and you can just, this is our transmission line. So that's a multi-line string because a transmission line is a big long line, and sometimes their geometry is a bit broken, so you have a couple of lines. But you can just, I want to show you how we do it. So when a user clicks on a map, you have your search distance and your search point. And then you can use the ORM to query that against the geometry of the transmission line. So here we get all of our transmission lines, and then we filter them where the geometry is within X distance of your search point. So then the query set's already constrained. The database does the heavy lifting here. And then finally, you want to order it by the closest line to where you clicked first. So we just annotate with that distance function, how far is this point from the line? And we order it and then splat it into the front end. So that's used everywhere in our code base, and it's really powerful. Something else I wanted to tell you about is the way we use projections and points. So in this picture, you can see there's two transmission lines, and the orange dots are transmission towers. So the towers have latitudes and longitudes, but that's not so useful because we want to know where are these towers along the line, like what percentage along the line is that, what span is that, and how can we filter it if it's a latitude and longitude? So we use projections, and this is straight out of the ORM. So you take, what tower.projection, what percentage along the line is this tower? So you take the geometry, project, normalize the latitude, longitude of the tower's point. And then you get a number between 0 and 1. And the other way around, given a tower's projection, what's the latitude, longitude? and we use that to say, yeah, where was this image taken? Or yeah, how far along the line is this image? Something else that I wanted to tell you about is a library called Portion. We use that a lot to tell us how much was inspected, how much was excluded because of no-fly zones. You can't fly a helicopter everywhere. And you can calculate the length of these distances too. So this is our model for an exclusion zone. It has a start and an end projection. So that's like between 0 and 1. And so here's how we build it up. So portion is imported, and you initialize it with an empty portion. And then we grab all of the transmission lines, the transmission line exclusions for a transmission line, that's foreign key traversal there, and we build it up into a closed portion from the start and end, and the result looks something like this. So that automatically coalesces overlapping unions. So like if you inspected the same line twice, and then you asked for the portions of the inspected areas, you wouldn't get overlaps. So like the overlaps would be merged together because that's what you inspected. So it looks something like that. And then you can calculate the length between it by walking along the line between those projections. Geomaths is really hard. You can't just take it as a percentage. Something else that we do is tables. So out-of-the-box HTML tables aren't very customer-friendly. You can't sort, you can't filter, you can't export. So this is more of a JavaScript thing. But we use a library called Bootstrap Table, but I just wanted to show you how we implement that in our application. It's actually ridiculously easy. On the Python side, when you call the view, we add in the data and the columns into our context. And then on the JavaScript side, we grab that as the data variable there is just grabbed out of the HTML. It's going to be passed into the HTML anyway, so this is just a way to grab it out. It just gets dumped in as a script block, grabs it, and then loads it into a table. That's something we use a lot, and customers find it very useful. That it's always like, I need that as an Excel spreadsheet, so this is how we give it to them. Another thing that I wanted to tell you about is because we self-host, we have a bit of a unique release process. I would say it's a bit more manual than I would like it to be, but we're ISO certified, and so everything sort of needs to be documented. You need to have all these quality processes. So it kind of goes hand in hand with that. We use Postgres, Redis, and Nginx, and they're all manually configured. And we use Conda to manage our environment. And the reason we use Conda is because we have system packages that we use for the geo stuff, geos and gdal. You need to install that system-wide. We wanted to have it like pegged at a version so that we can have the same thing across our dev, test, and prod servers. So that's why we use Conda. Something else that is very useful for us is Jake. Jake the snake. It scans all of your Python packages in your environment for CVE vulnerabilities. So we check this regularly, make sure that none of our packages are vulnerable, and if they are, we know exactly what needs to be updated. Another thing that I wanted to tell you about is fix-ups. So I haven't really seen this pattern much online, and we find it so useful because we write Python all the time. So if you want to clean something up, you write a Python script, and it's really simple. It's that's just a if name equals main, run main. But some cool stuff we do is argparse for the command line arguments. So the user has to type in save if they want to write to the database so that you don't accidentally do something really bad. But the important one here is that you can import Django with a little bit of environment variable manipulation, and then you can grab all of your models and interact with them in this script. That's the Django setup method there. The other thing is set query debug. So this is something that we do to view the database queries when running our scripts. So you basically you grab the Django database logger and you put it to debug level and pump it to the shell. And that's super useful because when you run a script, you don't get that feedback. You can't really debug your queries. With the Django debug toolbar, you can see it with requests, but when you're running it from the shell, you don't really get that. So this is how we do that. And that's actually the end of my talk. So thank you all for your attention.
Keep the round of applause going. Have a gift. Thank you very much.
Thank you.